Hello everybody, I am Megha Ramesh and I'll be explaining about the assignment 3 of Design and Analysis of Reconfigurable Systems. In this assignment, we will use Quartus IP generator and configure the given sine cos IP based on different specifications. That is, in the first part, we will look into how it's displayed in 5-bit LEDs, sine and cos, and the second part we'll display it on a 7-segment display. To start off, we go open a new project. Select the device that is Cyclone Phi D1 SoC board, and then we create a new project. And then after creating a new project, we usually go to File, create a new file, Verilog file. But then this time we go click here, click in Basic Functions, Arithmetic, and Altera Codec. So in this, we'll see the IP parameter editor. In our Altera Codec, we'll have to specify the parameters that is required for our IP that has to be generated. So we give an entity name. After that, we give the input and output data bits. Then we also change the frequency. Then we generate a new HDL file for the IP that we've selected. I've already done that and it's already generated. So after generation, we go to files and here we add all the files that is in the synthesis and submodule folder to the files. So there's already a Verilog file generated as we can see here. For this Verilog file, we add a test bench. The test bench indicates showcasing of sine and cos waves. And then we also add a synopsis design constraint file. So after this, we compile the design. You can see it's compiled well. After compilation, we go to Tools, Run Simulation Tool, and RTL Simulation. After we select RTL Simulation, Questa is open, and then we compile the test bench, and then we select the test bench UUT for showing the waveforms, and the waveforms are shown here. So these are the angles that we're giving. These are the cos and sine bits that we're getting as outputs. These outputs are verified later on the FPGA board through LEDs. So if the LED is on, it means it's 1, and if the LED is off, it is 0. So to prototype the code into the FPGA, first we go to Assignments, Pin Planner. So we assign all the input and output pins to the pins that is on the FPGA. Then we go to Analysis and Synthesis. Then we click on IO Assignment Analysis. This has already been done. Then we go to Program Device. Then we click on the file that has to be added. Then we prototype it into the FPGA. It's 100% successful. Now we can check the output on the FPGA. So we can check the output in our FPGA board. So these are the input switches. This is a reset button. And the first 5 LEDs that are shown here is for sine, the next 5 is for cos. So we give the outputs based on our waveform. So here the first input that I would be giving here is 0, 1, 1, 1, 0. And then to view the output, we just click on the reset button and it is seen here. So for the sine, the output is 0, 0, 1, 1, 1. For cos, it is 1, 1, 1, 0, 1. It is the same as what we get in our waveform. Let's try for another input. And on pressing the reset button, the cos input is 4 ones and 0, sine input is 0, 1, 0, 0. It can be verified from the waveform as well. To view the sine and cos waveforms, we can change the square waves into sinusoidal waves. Initially, we go and change the radix. To global signal. Of cos is done, now we do sine. The fraction bits and the precision bits for both sine and cos are kept as 3. For the input bit, we keep it as 7. Both of them are 7. And then the format of the waves have to be changed. We can keep the height as 50, so all 3 waves can be seen. Range can be 3 to minus 3. Okay. And run the code. And then zoom out, and we can change the format of sine and cos so that it looks bigger a bit. And yeah, we obtain our sine and cos waves as well. We also find the delay by clicking on Tools, Timing Analyzer. I've already done that here. We go to Timing Analyzer and then report path. After clicking on the report path, this is the delay that we're getting, 14.171 nanoseconds, and the critical path is from node A7 to an output which is in the sine cos cogdec library generated by the IP.